do. This won't be difficult. For the next couple of days, we're going to study increasing and decreasing intervals on graphs. And so Thursday, the goal was to get you to understand how to write an interval using interval notation. We did some other notations. We did inequality notation and we did number line notation. But starting now, you're basically just always going to use interval notation. So that was the one, remember, with the square parenthesis bracket and the round one and then the comma in the middle. Should be the one you like the best, honestly. It's way far the least annoying of all three and the most efficient. So anyways, today mostly is going to be done on Delta Math. I just thought I would show you an example of what you're up against here. So this part will be a little bit tough for you to do in your notes. So kind of up to you how you want to go about this. But what I'm going to do is make a graph. And mostly I'll just take today's lesson off of Delta Math. I just thought I would show you kind of a little bit more of what's coming tomorrow. Today's assignment, you're going to probably blow through it pretty quick. So after I get done with this lecture, which should not take more than about 10 minutes, you'll have the rest of the time to finish up the assignment from Thursday if you still need to. On Delta, I did only see a couple of 100% in there. And then you'll also be able to probably finish up the new assignment as well. So that would be assignment 30. And then the new one, which is assignment 31, which is assigning itself probably right about now-ish on Delta. So anyways, hopefully this isn't too confusing for you. When we talk about increasing and decreasing intervals, let's first talk about an increasing interval. When you look at a graph like this, and I know that we don't talk a lot about, like we won't actually graph cubic functions like this in this class, but we will study the intervals. When we talk about an increasing function, what we mean by that is when is the graph climbing uphill? And remember, math is always left to right. Like literally no one does that kind of stuff coming in from the other side. So when we study a graph, we're always studying it from west to east, left to right. So when we talk about an increasing interval, I want you to notice that on this portion of the graph right here, and I'm color coding this for your educational convenience, do you see that the graph is going uphill? Yeah. I will say that a decent percentage of the time, there are kids that say, no, the graph is going downhill. It's decreasing because the arrow points downwards, but that's not an accurate way to think. Because remember, we're always studying the graph as we move from left to right. And I know I've said that like dozens of times now, but as we move from left to right, I hope you all see, I heard Brendel say yes, but do you all see that the graph is climbing up a hill until it hits that apex right there at the peak? And then it switches to decreasing and it goes back downhill. And then it begins increasing again right here. And then it increases based on the arrow. We can surmise from that that it increases now forever. So the first thing we want to do when we look at a graph is identify which part of the graph is climbing uphill and which part of the graph is climbing downhill. Clearly, the two green intervals that I've color-coded for you are increasing intervals, and then the one interval in the middle that I didn't recolor because it was already red is a decreasing interval. You can see that during that time, the graph is going downhill, correct? So our job, now that we know how to do interval notation, our job is to identify those intervals. And the first thing you want to say, is that y doesn't matter. Like how high the y values of the graph, we're not interested in that at all. What I want you to say is, where on the x-axis could you say the graph is going uphill? Well, I'm going to put one of them, and then you're going to see if you can help me with the other. So we write it like this. We say this function is increasing over the following interval, from negative infinity to -3. And I'm going to have you stare at that and then, of course, add it to your notes. If you're taking notes on this part, which again, I know is difficult without graph paper, but you can always go back and rewatch this video and kind of have that, not during a quiz, but find a way to get it into your notebook. You should probably be curious as to why I put -3. You're probably not all too curious about the negative infinity. What I'm talking about here is that basically all of the x-axis over here, if I just kept going forever and ever and ever, if I just kept going to negative infinity on the x, you would agree that the graph below me is moving up, 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 up. It's climbing, it's climbing, it's climbing. Why did I stop my interval at -3? Why did I pick that randomly, Brendel?
No, because that's when the
What do you mean by that, where it starts?
where like the first graph essentially.
I don't think I like your answer unless you're saying something and I'm misunderstanding it. Are you talking about down here by chance?
Yeah.
We don't want that. Again, the y is irrelevant. How low this graph goes means nothing. I could keep going like this and this, and that means nothing to me, how low the graph goes. Where is the -3 coming from? I think I saw you first, and then if you don't nail it, then I'm going back to Gunnar.
When
Yep. What about it? When the increasing hits the peak, it happens right here. I'm going to draw a purple arrow to right where it is. That's the peak of the climb. Do we agree? Now, look down below the peak of that climb and count, go down. Doesn't matter how far down you have to go, but just go down until you hit the x-axis. Where am I on the x-axis when that peak, when it apexes? There you go. So this value right here is why I stopped my interval at -3. The increasing ceases to happen the moment the graph arrives at -3. It climbs, 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 climbs from negative infinity. In other words, negative infinity means forever to the left. The graph is climbing, 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 but then it gets to -3 on the x-axis and says, I'm done. And what does it do at -3? It starts to decrease, right? Having said that, I'm going to switch colors now. I'm going to scoot this up just a little bit like this. Can anyone name for me the interval over which the graph decreases? This one does not involve infinity, does it? Like this one, I can't say that it goes and increases like from here to infinity. It starts at what x value does the decrease start? Nope. Nope. At -3. The exact same place, think about if you're on a roller coaster, the exact same place where you stop going uphill is the exact same place where you start going downhill, correct? And so if the increasing interval ceased to be increasing at -3, it immediately begins to decrease at -3. So my red interval, my decreasing interval, occurs from -3 until right here. You agree? It's where that red arrow is pointing that if you look down below, that's the base of the graph. That's the moment where he says, I'm done going downhill. What is the x value that I'm pointing to? So the decreasing interval goes from -3 to 1. Now, I left a little bit of space here, but I'm going to probably just slide it over like this. Isn't there another increasing interval as well? So what we need to do when this happens, and this won't happen on today's, I'm just, like I said, I'm kind of getting you warmed up, getting a little bit of the stuff for tomorrow kind of out in the open. You have to say increasing over da, 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 and there's another interval too, isn't there? This last green arm right here where you kind of see I'm moving my pen, that also is an increasing interval, isn't it? And where does it go? From where to where? From 1 to infinity. Done. This is what you're going to be studying and practicing over the next couple of days. Today's is a delta math, and I'll show you that the delta math one is pretty straightforward. Tomorrow's is a worksheet that is more difficult. It's got more intervals. Today's graphs are pretty predictable. I haven't clicked through like 100 of them, but from the dozen or so that I've clicked through, they look like they all just have a couple of intervals. They're all what we call parabolas, you'll see. There's a pretty good chance that what I just showed you how to do is really, really confusing. So don't feel like there's something wrong with you if you looked at that and went, I have no idea what the man just said. It's a very overwhelmingly abstract concept at first, but what you eventually come to realize is that really I'm just studying this axis. I'm only interested in what are the stopping points along that yellow x-axis where the graph changes behavior. Where does it stop going uphill, start going downhill, then start going uphill? We're just marking off the points where the changes. Pretty confusing? Not too bad. Let me show you what your actual assignment's going to look like. I don't want this to take too long, so we'll head on in here. And it'll say determine the domain. By the way, that's a word you'll start getting used to. The domain is just the set of x values. So whenever anyone says talk about a domain over which blah, blah, blah happens, they're just talking about the x values, just like we did in our example just now. So take a look at this graph. You should see, based on what you just sat through, that it has two intervals, right? It has one interval that goes, and I'll use my same colors again. It goes here to here. And what kind of interval is that? That's an increasing, very good, because the graph from left to right is always going uphill on that green part. And then starting here, it goes downhill, and that is what we call a decreasing. So all we want from you is to give us the interval that is asked for. So like in this case, delta math, I know you can read, but it says up there to determine the domain over which the function is increasing. So we want to describe for the computer the green one, correct? Remember, y doesn't matter. How high the graph goes, how low the graph goes, doesn't mean squat. What x value does the increasing interval start at? Very good. So when I go to describe that increasing interval, I'm going to put in, by the way, I vandalized this so you can't see this. Let me see if I can erase just a little bit of it. Boop. Do you see how underneath there, you probably can't see how there's a solid circle? So it does start at 0. And so I need a square bracket for my left-hand side. So when I go down here and select my notations, I'm going to pick a square on the left. I didn't answer this question in my example. Why would I want a rounded one on the right? Right. Let me ask you a question. I'm going to put a dot right there. At that infinitely small dot, is the graph increasing or is it decreasing? Oh, neither. And that's why that point, that endpoint has to be left out of the interval, because at that apex, the roller coaster is not climbing uphill and it is not going downhill. There's an infinitely small, and you'll study these points a lot in calculus, there's an infinitely small moment in time, just boom, where it's not going up and it's not going down. So we want to leave that point out of our interval. At that point, it's not increasing, it's not decreasing. So that point isn't going to be a member of either domain, increasing, decreasing, whatever. So we want to go from 0. So I'm going to go back and type this in. I'm going to go from 0 to what? 5. Very good job. You're just looking only at the x coordinate on those points, not the y coordinates. And I'll tell you again, let me get rid of my vandalism here. You'll notice that in all of the graphs, they're parabolas, aren't they? So here, I'll just do another one. Boom. Another one. I was kind of hoping there'd be a little more variety, but honestly, it's okay. Let's practice again. So when we talk about an increasing here, because you just got to read this word. I'm sorry if you're confused, but it says right there what to do. So we just want the one interval that increases. Is the increasing side the right or the left? The right is where the graph's going uphill, correct? So where does that interval begin? I'm sorry, I know it's really, really small. Yeah, so you can see that right here is 2. And so that's the moment where the graph begins to increase. And so when I set my interval, what kind of boundary do I want on the left? Round or square? Round, because remember, 2 is not actually increasing. 2 is an infinitely momentary little glimpse of doing nothing. It's flat. It doesn't look flat, but it's infinitely small flatness. And so I want a rounded bracket on the left. And what kind of bracket do I want on the right? Another round, because how far does it go? Forever. The arrow tells me, unlike that last graph, this time the arrow says, I go forever. You go forever to the right, and I'm going to keep going up. Go forever to the right, I'm going to keep going up. So we actually have 2 rounds on this one, and it goes again from 2 to infinity. And if you, oops, my bad. And if you wanted a negative infinity, you would just have to add the infinity sign yourself. Got it? So that's what you're doing with this particular assignment, and it'll give you a little visual aid to kind of guide you as you look at these. It does a good job with little arrows. Let's find a decreasing. Here we go. What would you say about decreasing on this one? Decreasing is going to be from this side, right? Because it goes downhill. So it goes from, say again, 7 to what? Why no infinity this time? Because it ends, right? There's no arrow this time. And so it goes simply from 7 to 15. Should 7 have square or round? Right, because remember, 7's not increasing or decreasing. So we want round on the left, square on the right. Because at 15, 15 is still included in the graph, right? And actually, I think it might mark this one wrong. Let's take a look. I hope it marks it wrong so we can learn together. It may not actually be like this. It might be round because I'm not sure that it counts as decreasing, but I think it does. Let's send this. I think this will feel good. If it's wrong, then we'll know. So it's going to go 7 is definitely rounded and 15 is square. And if it marks it wrong, well, there you go. So it did still count that point as a decreasing point, even though technically it's kind of an end, but yeah, that'll work. So any questions about that? So tomorrow is going to be a much more difficult assignment. It's going to have lots of little graphs. I'm going to try to make this look better and get it onto less pages for you. And it'll have intervals that go like up and down and up and down. And you'll have like 3 or 4 different intervals that you have to name on each one. Today's is pretty simple. So that's that. If you have any questions, let me know. Okay. Remember, you're working on assignment 30 from Thursday if you still need to, or working on assignment 31 that just showed up a little bit ago. So.